Eureka!
This unit is divided into 6 programs. The program you're about to see is on molecules in solids. Then there's a program on molecules in liquids, followed by one on evaporation and condensation, another on expansion and contraction, and then a program on measuring temperature, and finally a program entitled Temperature versus Heat. But our story begins with molecules in solids. You've probably noticed that everything in the universe fits into one of 3 categories. It's either a gas, like the delicious vapor just now floating up from your soup, or a liquid, like the soup itself, or a solid, like your soup spoon. These are the 3 states of matter: solid, liquid, and gas. And you probably also noticed that gases move about very easily. So do liquids. But what about solids? Do they move about easily? It certainly doesn't look as if they do, does it? Not of their own accord, anyway. But the funny thing about matter is that it never stops moving, even when it's in a so-called solid state. Strange as it may seem, even things that aren't moving are moving. It's just that you're too big to see what's going on. Now, if you could shrink and shrink and shrink, eventually you'd be small enough to go to the dance. Yes, the dance. Every supposedly solid and motionless object, including your soup spoon, is in fact teeming with billions and billions of little lumps of matter, all dancing about as fast as they can. Don't be afraid. Come in. There's plenty of room. Join the dance. The steps are easy to learn. Each little lump keeps moving towards its neighbor and then springing away. Let's zero in on that couple over there and see exactly how it's done, in slow motion. Molly and Marvin attract each other. Come closer, and then suddenly change their minds, but not too close, and seem to push apart again, and to try to escape from one another. But they don't get too far before their mutual attraction pulls them together again, only for them to repulse each other once more, and so on, and so on. And all the little lumps are doing this to one another. They're all playing, now I want you, now I don't, alternately attracting and repelling each other. You try it. Together, stop, apart, together, stop, apart. Easy, isn't it? It's as if you're joined by an invisible spring. Had enough? Relax for a moment and watch the others. They never quite touch each other, but they never quite escape from one another either. And when you look at a whole lot of them doing it, you see that they make up a kind of lattice work. It's this lattice work pattern of little lumps that always stay more or less together that makes a solid a solid. That's what keeps solid things from falling apart. So next time you pick up a spoon or any other solid object, don't be deceived by its deadpan appearance. There's a lot more going on than meets the eye. Remember, the dance of the little lumps. Of course, if you want to be scientific about it, you won't actually use the phrase little lump. You'll take the Latin for lump, moles, and the Latin for little, cula, and you'll say moles cula, or molecule, so that you can remember the dance of the molecules.